So look at the diagram once again. This is the source, plus minus. Current I is coming out. Let's say current I is coming out through ammeter and key is on. 3 ohm resistance is there. At this point, current I is divided into two parts, I1 and I2. So it means that beyond this point, the resistors are in parallel. But how many resistors are in parallel? See, here I1 current is flowing through 3 ohm. There is only one single resistor in this line. So only I1 is coming out from here and getting up to here, this point. But at this point, I2 is going through 3 ohm and same I2 is going through 3 ohm. It means that these two are in series combination. So these two combination are in series, and this is along with this is in parallel. So let's simplify this diagram. And one more thing, when this I2 come to this point, so I1 plus I2 both becomes I. At this point it was I current, and when it joins over here again, then again it is I. So how to identify that which all resistance are in series and which are in parallel? Simplify this diagram. I am drawing it in this way. This is 3 ohm, single 3 ohm, and here are two 3 ohm resistors. And again here one more 3 ohm resistor. So this diagram is simplified as 3 ohm, 3 ohm, 3 ohm, 3 ohm and 3 ohm. When we join this is the source, positive, negative, ammeter and key, the circuit is complete. So to get the circuit voltage, now the question is, if R1, R2, R3, R4, R5, there are 5 resistors, R1, R2, R3, R4, R5, each are of 3 ohm, find the equivalent resistance of the circuit. Just you have to calculate the equivalent resistance of the circuit. So this is the simplified version, simplified diagram of this circuit. 3 ohm, 3 ohm, 3 ohm plus 3 ohm. Again, let's further simplify this. This can be broken down into, this is 3 plus 3 is 6 ohm. So this is broken down into 3 ohm, 3 ohm, and if we put a single resistor of 6 ohm, this is 6 ohm, 3 ohm, 3 ohm and 3 ohm. So this is the simplified version. This is the simplified version of this one. This is the simplified version of this complex diagram. So now find out the equivalent resistance of 3 ohm and 6 ohm. To find out this, 1 by R is 1 by 3 plus 1 by 6. Equivalent resistance in parallel is given by 1 by Rp is equals to, formula is 1 by Rp. Equivalent resistance in parallel is 1 by R1 plus 1 by R2 plus 1 by R3 and so on. Reciprocal of each resistor. So this will become, simplify it, LCM is 6, 3 2 times, 6 1 time, 3 by 6, that is 1 by 2. So 1 by Rp is 1 by 2. So Rp resistance in parallel is 2 ohm. Now further simplification. This parallel combination can be replaced by a single resistance of 2 ohm. If we draw this simple diagram, this one is 3 ohm, single 2 ohm resistor. If we replace these two resistors by a 2 ohm resistor, these two resistors, equivalent of this combination is 2 ohm. Let's replace these two resistors by single 2 ohm resistor, and then again 3 ohm. Now tell me, what is the type of combination here? Now these three are in series. Now the resistance, equivalent resistance in series is given by R1 plus R2 plus R3. So here equivalent resistance in series will be 3 plus 2 plus 3, that comes down to 8 ohm. So the equivalent resistance of this combination is 8 ohm. Circuit resistance. This is the circuit resistance, the resistance of the whole circuit is 8 ohm, provided that there is no internal resistance of the cell. There is no internal resistance of the cell. although you will get numericals based on that also. But here in this particular question you are asked to just calculate the equivalent resistance of the circuit. So this is the equivalent resistance of the circuit. So break down the complex diagram into simpler one, more simpler one, more simpler one. In 2-3 steps you can simplify the complex diagram and get to the answer.